Alright, I know it's been a long time. There's been a lot of stuff going on, but I'm going to try to get some more videos out for you guys. And right now I have a JL Audio 250/1, and it's got an issue here with the power. It won't turn on. Let me get some power over here and I can show you guys what's going on. I'm just going to hold it in there for right now. And let me get my turn on lead. Normally I would actually bolt these down, but there's no sense right now. I'm just going to use a, let me just use this for the turn on lead for temporarily. Guess it helps if I turn the power on. And we get a power light, and my current's jumping way up, and then we get a low ohm light. And that means that there is something going on in this amplifier, something shorted, if you get that. And drawing a good bit of current right now just for being in idle mode, so let me undo that because I don't want to make anything worse. Yeah, we were drawing over 5 amps just sitting there on like that, so definitely have an issue. And I have already taken the bottom off of this amplifier. It's just 3 little Phillips screws to take the bottom off. I'll just flip it over here, and the bottom just flips over into this little thing like that, and then the screws go in like that. Nothing to that. Now, these amplifiers have a special type of hold down for the transistors, and it can be kind of common to see these, and at first they look really complicated to get off, but they are actually pretty easy. I'm going to start with the power transistors over here. This is your actually, this is the power supply section here. This is your transformer. This is the output stage. So I'm going to start with the outputs just to see if any of those transistors are shorted. And I need to grab my meter. Alright, got my meter sitting here at the side. I'm going to show you how to get these hold downs off, and it's actually a lot easier than you would think. Turn my whole mat here. I use a pair of pliers that actually has a bent tip to it. I did have a little screwdriver that I had bent the tip on, which actually worked really well. I don't know what I did with it off the top of my head, but this works just as easy. And all you do is just put the tip of the screwdriver, whatever, in the hole like that and act as a lever. And when you do that, you just pull and it pops right off. You just apply a little bit of pressure there, boom, pops right off. And there's another trick to getting those back on, which is actually also pretty easy. And let me get in here, try to keep all this in focus here. I'm going to put my meter in diode check. And these amplifiers are usually pretty good amplifiers. They in general don't have a lot of issues. So that's why usually I just kind of check for the outputs first. If there's no problem there, I'll check the power supply. You can check both. Usually with these amplifiers, if I see a couple shorted transistors over here, I'll just go ahead and replace those and just power test it for a second. Obviously, if the power supply section has got something wrong with it, you're going to see an issue right away. Now, to get down in here, the case of the transistor is always the same as the center lead right there. So that makes it a little bit easier when testing. So I'm going to get the case on one side, and then I'm going to test on the other lead. And we got 0.7 there, 0.3, Let's reverse these leads. And it's charging up the capacitor, so got 0.4. Okay, that one is not shorted. Move to the next one here. Okay, looks like this next one is actually shorted. Either lead, checking from the case to either outer lead is shorted there. Let's move to the next one. Yeah, we got 0.5 there. And this one here, 0.5, 1. I'm going to reverse the leads on that one. And charge up the capacitor. Yep, so looks like this transistor right here is the culprit. So what we're going to do is go ahead and take this amplifier apart so that I can get to those easier. And actually the best way to do this without risking breaking any of the other leads is go ahead and take these rest of these hold downs off. And like I was saying before, the screwdriver that I had set up actually worked a little bit better than these pliers, but anything that you can get in there with an angle and just pull down, just kind of hold them so they don't pop all over the place. And another thing I like to do is actually just make sure that the transistors are pulled away from the heatsink. Sometimes they can stick, and when you go to pull the heatsink off, it can just kind of make a mess. And be careful not to damage the insulator between the heatsink and the transistors. Alright, now to disassemble this one, there are 4 screws on either side here, and it is a 2.5 millimeter Allen key. If you try to use a standard, it will fit, but it'll be a little bit loose and you'll end up stripping the screws out. So I'd highly recommend finding a 2.5 millimeter Allen key so that you won't have that issue. Take that off, set it aside. And we can flip the amplifier around, get the other. It's the exact same setup on this side.
It was pretty tight.
All right, and there are 3, whoops, there are also 3 Allen key screws up here, and these are a 3 millimeter in size, but I'm not going to take those out quite yet, because if you do not take everything out of here, as far as the nuts for the RCAs, it kind of makes it a lot harder to deal with, because you'll end up having everything kind of flopping around. So what you want to do, and I'm just going to use these little pliers here just to loosen these. It would actually be better to use a socket. That way you don't risk making a mess of the nuts or slipping and scratching the front of the amplifier. This is my amplifier, so I'm not too worried about it. But if I was doing this for a customer, I would be as careful as I could possibly be to not damage anything. And then we're going to go ahead and take these out. And these are usually pretty tight, so I'm going to loosen all of them with the small end and then take it out with the large end. Alright, and we're just going to slide this apart like this, and you're going to be careful because there is a wire here that attaches the LEDs to the board, so you don't want to just lift that thing out of the way. We're just going to set that top heat sink aside, and the one that we were concerned with is the transistor right here. And best practice, if you have a transistor in a group like this, they're actually all matched. So the best thing to do would, if you find one that's bad, is to replace all of them. Just for this video, I'm just going to replace the one. Like I said, this is my amplifier, so you know, I'm not too worried about it. But if it was a customer amplifier, I would replace all 4 of these just to make sure that they're all close within the right tolerance and within the right specs. But it would be best to go ahead and replace all these at once from the same lot of transistors. And normally, if you order transistors like this from, say, Bowser or DigiKey, they come in a tube, and normally all those transistors are very close to the same tolerance, so and specifications. So we'll just leave that as, got some fell off there. Move this over a little bit so I can try to keep that in focus. And there are different ways to go about removing these transistors. I'm going to use my desoldering tool. However, if you do not have one, the easiest way to get these transistors off would be to flood all 3 leads with solder so that you can heat all 3 at once, and then with some pliers just gently, don't pull because you could damage the pads, but while you're heating the whole area with solder, all 3 leads, just put just a little bit of pressure on the heat sink and it'll pull right out. And then you can solder wick off the rest of the leftover solder. Alright, looks like my desoldering tool is heated up. As you can see, the transistor actually fell right out as soon as I got to that 3rd lead. And if you ever have trouble reading a transistor to see what the text is, just take a little bit of the heatsink compound from the back, rub it into the numbers, and then it really shows up well. So that's a let's see which one that is. Looks like a IRF 540. And I'm going to unplug my desoldering tool. And I'm going to double check this transistor just to make sure that it is the bad one. Yep, it's completely shorted. And like I said before, since this is my own amplifier, I actually have some other transistors that I keep as spares that I've removed from other amplifiers that may be still good out of a group. I would not recommend doing that again if this was for a customer, or maybe your amplifier, you don't want to have to go back into it again, but just for the purpose of this video, that's what I'm going to do. So I've got a few here. I'm going to check off camera, make sure I've got a good one. Alright, here we go. I just have this transistor here. I'm going to check. And actually, of course, these are FETs, the field effect transistors. These are actually so sensitive that you can turn them on with the meter. I'll show you what I mean. If we're measuring here, we get 5 volts. And if I touch the lead to the gate right here and then go back to the drain, it actually turned that transistor on. So it's actually not shorted. But if we go back here and I reverse the lead, which basically turns it back off, see, we have 5 again. I'll show you what I did. I went over here to the gate, go back to the drain, and you can see that's actually turned itself on again. And then I'm just going to reverse the leads, and then it's back off. So you can actually test FETs like that with these particular type, because they are pretty sensitive to the gate voltage. Made a little mess there. And I'm just going to solder this one back in because this is good. And just in case you're wondering, this particular used transistor that I have did come out of another JL amplifier that I'd repaired. Same model. Guess that would help if I would turn my iron on. Give me a second to let that warm up. I just wanted to show you how the transistors come if you buy a bunch of them. They come in these packs like this. This is actually a direct replacement for the ones I've got in there, but if you notice, this is an IRF 540N. These are actually capable of handling just a little bit more current, and if I was to replace these, I would use, all of these. Obviously, you do not want to mix one of these and one of the other types, because then one transistor would be capable of a higher load than another, and you'd have a really bad mismatch problem. But like I said, for this being my amplifier, I'm just going to do it that way. And a lot of transistors will come in packages like that, and it would be fine to use ones like that. There's all different types here. They all look the same, but they all are a little bit different. So just wanted to show that. And we're going to solder this one back in. Should have actually zoomed in a little bit so I could show that better. Alright, well, let me go ahead and put these little pieces fell off here on the other side. And I'm going to get a little bit of heatsink compound here and just add a little bit to the transistors. It's always a joke, this stuff gets everywhere. So I'm just going to spread some on the back of the transistors here. Just to make sure that they do have enough, since I had it apart. And if you're wondering what kind of heatsink compound I use, this is the Dow Corning 340. This is basically the same type of heatsink compound that they would have used on the amplifier when it was designed, so I always keep some of that on hand. Be careful. I keep bumping the camera there, sorry about that. And this wire, just again, make sure, just be careful with it, make sure it doesn't get pulled or pulled away from the board. I'm just going to pull the heatsink back on there. It's hard to see, but there's actually a groove that the board fits into. Let's see if I can show you. It's kind of hard to. Right here, the board actually goes into this slot right here. So when you have that lined up, it's kind of tough to get that whole thing lined up. What I've found that makes it a little bit easier with these particular type of design is to go ahead and grab one of the end pieces and put the screws in it to help align that back heatsink. You can see how it likes to fall apart. Don't tighten that up completely. I guess it would help if I was on camera with that. I'm just going to move it forward here. This is what I was putting on the end piece here. And then to help align everything, I'm going to pull that up and then get that into place like that. And then again, just put the screw in. And don't tighten it down yet, because we're just kind of using this for alignment. Now you can test the amplifier with the heatsink off. Don't really recommend it because the transistors can get pretty warm pretty quickly, and you don't want to blow out or short one of the other ones. I'm going to put the other end on. And there's also a little groove that the circuit board fits into right here on this side. I'm kind of reaching away from what I'm doing here, so it makes it a little bit harder. And I'm not tightening these screws down all the way. Alright, I'm going to go ahead and snug these down. Everything should be aligned. Then I'm going to go ahead and snug down the ones on the ends. put the washers and nuts back on the RCAs. Okay, and we're back to these strange hold downs for these transistors. So, the way that this works is you will put the hold down over top of the transistor, align it correctly right to left, and to make it easier, you can actually get, say, like a 1/4 inch nut driver, and if you put like a little bit of insulation from, say, a 10 gauge piece of wire down in there, it actually helps hold it. If you put a little bit of insulation and let it hang out about, I don't know, maybe a 1/16 of an inch, they can help you hold it. I don't have any right now, so what I'm going to do is I'm going to align it. I'm going to slide it in there just a little bit. I'm going to put the nut driver here, and then I'm just going to tap the back of it. And that's it. That way it actually hooks down into that little rail, and that's all you need to do. And that's it. They've got plenty of tension on them. They're good to go. Alright, so let's go ahead and test this amplifier. Alright, I'm going to put some power to it here. Hook up our remote lead. Alright, we got our power light. And it is not drawing 5 amps any longer. The gauge barely moved, so alright, looks like we're good there. Let me disconnect this, and we'll hook some audio to it to test it. Hook a couple speakers to it. 2 over here. All I need is 1. Some music from the YouTube library. Alright, I'm going to turn this up here. Go back on the track. And of course I've got the low pass filter on, so let me turn it off here. Low pass. about 65 hertz. Now this is just connected to a 6x9, so it just kind of rattles more than anything. Actually, let me go grab a bass tube and hook up to this thing. It'd be a little bit more appropriate to test the bass in it. Alright, I got an actual subwoofer hooked up to it now. It'd be a little bit better. Not the greatest song to test this with, but alright, well anyway, that shows what's going on here. It looks like it's working good. There's no heat at all. I think we're done. Well, if you enjoyed what you saw, please give me a thumbs up and like, subscribe, all that good stuff. There'll be plenty more videos to come. I've got a lot of content. I just need to get it out there. So thanks for watching, and I'll see you next time. Or you'll see me next time, rather.